In order to understand differentiation, we need to start by looking at the gradient of a line, or you might say the slope. So on the screen we have the line y is equal to 2x minus 1, and of course using the formula y is equal to mx plus b, we can clearly see that 2 is the gradient of this line. But the point of this video is to understand everything from scratch. So we choose a random point on the line, and then another random point on the line, and since the gradient is the difference in y divided by the difference in x, I put these numbers into the formula, and I get, not surprisingly at all, 2 as our gradient. But now I will ask you an interesting question. What is the gradient of this curve? Does that question even make any sense? I mean, from what we know about gradient is that it's the rise over run. But the thing is, with a line, I can choose any points I want and I will get the gradient. But if I apply the same logic to a curve, I will have a different gradient depending on which points I choose. So the question is, how do I solve this mystery? The thing is, it does not make any intuitive sense for the curve as a whole to have a gradient, but each point on the curve has a different gradient. To understand this, we draw a tangent to the curve at a point. A tangent is a line that just touches the curve at that point, and we record the gradient at this point using the formula we have for the gradient of a line. But I mean, this can get very tedious. Imagine drawing a tangent for every single point and calculating the gradient at each point. It would take you forever actually, because this curve never ends. What if I told you that I can give you an equation, and as soon as you plug the x coordinate into the equation, you will find the gradient at that point? Sounds like magic, right? But really, that's the power of a derivative. And for this curve, the equation is highlighted on the screen now. Now the main question is, how did I get to this formula? And the truth is that each curve will have a different formula. But first, let's check that we are correct. I will draw a line that cuts through some points very close to the point in question, and we can see that the gradient is not exactly what we got from the formula. However, now I will draw a line that's even closer to the point, and we can see that we're getting closer and closer to the gradient. The closer and closer we get to the point, until we eventually reach the point, the closer we get to the true gradient.